Part of lecture 4, and in this part we'll learn about some more sensors and their controlling system. So first, dissolved oxygen control, that is DO control. Okay, so in most aerobic fermentation, it is essential to ensure that the dissolved oxygen concentration does not fall below a specified minimal level, because if the DO falls below the minimal level, the yield will be less, because it, I mean, in that case the microorganisms, their growth will be slowed down, so that's why the microbial biomass yield will be low. Okay, and the most common method of measuring DO is based on electrochemical detector. Okay, and there are two types of detector: galvanic and polarographic detectors. And in both these detectors, there are membranes. Okay, so membranes are there to separate the cell components from the broth. Okay, so the membrane must be permeable to oxygen only and not to other chemicals. Okay, so what that means, the oxygen diffuses from the media will cross the permeable membrane to the detector, nothing else, only the oxygen. Okay, and once the oxygen is oxygen reach the detector, then it is reduced at the cathode to produce a measurable current or voltage which is proportional to the rate of arrival of oxygen at the cathode. Okay, however, the probe has to be calibrated for accurate measurements. Actually, this is true for every probes. Okay, so whether it's a pH detector, or it's a dissolved oxygen detectors, or carbon dioxide detectors, any electrochemical probe, they routinely need to be calibrated. Okay, okay, now pH control. So pH measurement, how pH is measured by using glass electrode. Okay, and the electrode may be made of silver or silver chloride with potassium chloride as an electrolyte. Okay, sometimes mercury electrodes are also used, and the electrode is connected via leads to a pH meter or controller, and a recording unit may be wired to the meter to monitor the pH pattern throughout the process cycle. Okay, so usually in the fermenter, actually it's a continuous process. I mean, this detector, the probe continuously measure the uh, pH value, and these values are continuously recorded. Okay, so, what is the working procedure of pH meter? Rather, you can say that the working procedure of the pH controlling system. Okay, so first, a signal actuates a relay. That means the pH meter, the probe of the pH meter, it's detect the pH. Okay, so if there is any aberrations, then a signal is relayed. Okay, and it cause a pinch valve is opened or a pump started. Actually, in the pH controlling system there is a pump. Okay, so whenever there is a aberration in the value of the pH, then this pump, it opens. Okay, and then it allows some acid or alkali to pumped into the fermenter for a short time. Okay, and addition cycle is followed by mixing cycle, which is governed to another process timer. Actually, okay, so and at the end of the mixing cycle, another pH reading indicated, so adequate correction of the pH drip. So the probe, they detect the pH probe, they detect the pH. So if there is any changes from the standard value, then it creates a signal which signal the pump that, okay, so I mean there is a changes in the pH value, so it's need to be adjusted. Okay, so based on the signal type, so that valve, okay, the pump, they either add a alkali or a acid into the fermenter. Okay, then a time should be allocated there, because the alkali or acid will mix with the media. Okay, so it need some time to mix properly and change the pH. Okay, and after that, the probe, it will detect the pH, and if it is adjusted, okay, it's done. But if it is not adjusted yet, then again it will generate a signal, and again that signal will allow addition of some acid or alkali into the fermenter. Okay, and in the pH controlling system, we actually we all know, right, the pH is controlled by using buffer, and this buffer can be a I mean this buffer, and there are two types of buffers are used: acidic buffer and basic buffer. Okay, so if the media pH of the media is too basic, then acid need to be added, and sulfuric acid is a good choice as a buffer. Okay, and if the pH of the media is too acidic, then basic buffer need to be added, and ammonia and sodium hydroxide are most frequently used as a basic buffer. Okay, then redox measurement. Okay, so it is a measurement of the oxidation reduction potential of a biological system and can be measured or determined as a voltage. Okay, so how we can use the value of the voltage to measure whether it's in the reduced form or oxidized form. Negative value means reduced form, and positive value means oxidized form. Okay, so and the measuring electrodes, the electrodes that is used to measure redox potential are made of gold, platinum, or iridium, which is welded to a copper field. Then carbon dioxide electrodes. So the measurement of dissolved carbon dioxide is done by electrodes. The first available electrodes consist combined pH electrode with a bicarbonate buffer surrounding the bulb. Okay, and now the permeable silicon bilayer membrane is used that can detect internal bicarbonate electrolyte. Okay, so this was all about the sensors. I mean, I almost talked about all the sensors which are used in a bioreactor to detect different parameters, and how how these parameters are controlled in the fermenter. Okay, so nowadays actually computer is frequently used. Actually, not frequently. Computer has become a kind of integral part of a fermenter process. So everything is automated nowadays, right? So people are trying to automate everything. Automation is everywhere. Okay, so similarly, in fermentation technology, many different computer applications are used. Okay, many computer softwares, programs are used in the fermentation technology, and day by day the fermentation technologies are getting automated, especially in the large scale industry. I mean, there are many traditional fermenters there. Okay, so traditional fermentation process, they are more focused on the producing beverages, especially alcoholic beverages. But I mean, beverage producing is not the only purpose of the fermentation, right? Because fermentation is used to produce many different things, many electrolytes, vitamins, enzymes, hormones. Okay, so if those systems are like, say for example, you are producing hormones, so that means a say you are producing hormones, so reproducibility is important in those cases, because if you're producing, if you're producing uh, beverage, alcoholic beverages, so slight changes from batch to batch is okay, right? So if you're doing in the traditional fermentation and there is slight change, actually, that's an one, it's an attractive feature of the traditional beverages, because there is a slight difference in taste in each batch, and slight difference in quality. That quality means the taste basically. Okay, so this is the attractive feature of the alcoholic beverages produced by traditional fermentation. But if you are producing antibiotics or hormones, such kind of products, it's very important that quality is consistent from batch to batch, and to ensure that automation is necessary. Okay, so if you can fully automate everything, then the chance is high that the product will have a reproducible quality. Okay, so let's talk about computer applications in fermentation technology. So three distinct areas of computer function were recognized. Number one, logging of process data. Number two, data analysis. and number 3 process control. So first, logging of process data. So data logging is performed by the data acquisition system, which has both hardware and software components. The software should include the computer program for sequential scanning of sensor signals and the procedure of data storage. Okay, so everything is measured and everything is stored. Then data analysis. So data reduction is performed by data analysis system. Okay, so that means data analysis allow to reduce the logged data. Okay, so and which is a computer program based on a series of selected mathematical equations, and this analyzed information may then be put on a printout, fed into a data bank, or utilized for process control. Okay, so say your your process control system is automated. In that case, actually the system will continuously access the data. They will process the data, they will analyze the data, and then they will use this data to utilize the process control. So for example, the pH meter, okay, it's continuously uh, recording the data. Okay, and that data is processed and then analyzed, and then this analyzed data is sent to the pump. That okay, so after after the analysis, the computer measured that now this amount of alkali or acid need to be pumped into the fermenter to adjust the changed pH. Okay, then process control. So process control is also performed using a computer program. Signals from the computer are fed to the pumps, valves, or switches via the interface. And in addition, the computer program may contain instructions to display devices or teletypes to indicate alarms, etc. So you can say that these three logging of process data, data analysis, and process control. These are like the three step of automated uh, controlling system, process control system. Okay. So anyway, there are two distinct fundamental approaches to computer control or computer control of fermenters. One, fermenter is under the direct control of the computer software, that is termed direct digital control, DDC. Okay, or another approach is the use of independent controllers to manage all control functions of a fermenter, and the computer communicates with the controller only to exchange information. This is termed supervisory set point controller. Okay, control, SSC. Actually the DDC is kind of a fully automated system, but in the SSC, it's you can set it like a more manual, so you can put some manual intervention options in the SSC approach. Okay, so so that was all about this chapter, which is about instrumentation and process control. Thank you for your patience.